Yes, sir.
Thank you for the confirmation. So, welcome to week 6 of this course on Python. So, today we will discuss some of the assignment questions that were uh, offered during the last offering of this course. But before that, if you have any questions, any doubts, we can talk about it for some time. So, let's get started. So, this quiz was due last year sometime. So, this is the first question for you. I will let you read the question for some time.
Good morning, sir.
Good morning, good evening as well. So I hope that you have watched the videos and this week,
The
uh,
answer should,
yeah,
if
you
you
were
can
saying
keep,
something?
yeah. The answer should be uh, you uh, you and we should be disjoint, right? The sets should be like
Okay, so
so.
fine. So even we should be region, that is option one. Rather, this is, let's say, option A. Okay, so why should even we be disjoint?
If we solve v minus u, that will leave us with either v or u, that is, and u minus u, then it's essentially u. So
Mhm.
mm,
Okay.
it seems to be they both should be disjoint sets, but somehow it feels like it should be true for either the last option. This is true for any u and v.
Okay,
I'm getting confused now between both the options.
that is fine because you have confusions. That's why you have come. So let us see what it means. All right. So the question is, this is again some 2 seconds. So we have seen the concept of sets in Python. So initially we have seen lists followed by dictionaries. Then we saw sets in the previous week. So even we are two sets in Python. And the question is, if you do this operation on the two sets even v, then in what situation the left hand side will be same as the right hand side. So what is on the left hand side? Left hand side we have first taken the difference, this set difference operation v minus u, and then we have subtracted from u v minus u, So in what situation, in what condition, the left hand side should be equal to u. So that means, uh, so it doesn't really affect you. So left hand side, whatever we have done doesn't really affect you. Let's see, there is some message on the chat box. I will check that. Salmabi 3. 3 means option 3. So Salmabi says option 3.
Yes, sir.
Okay. The set U should be a subset of the set V. If the set U is a subset of the set V, then V minus U will be something, and then U minus that thing will not affect you. That's what you are saying. Okay. So how many of you remember Venn diagrams from school? So try to think in terms of Venn diagrams. Try to draw the Venn diagram for U and V and try to do this operation, set difference operation. So I will write it down. So are you able to see the whiteboard?
Yes.
Yes, sir.
All right. So these are expression. Okay. So I will draw Venn diagrams. The easiest thing to do is to draw Venn diagram. So there is a set U and there is a set V. They have some intersection among them. We do not know. As somebody said that one could be a subset of the other. If that is the case, something is contained within the other. That is a subset situation. So this smaller thing is contained within the other. The other situation is they're disjoint. There is no common elements. The most general situation is there is some common elements and some elements are unique to both the sets. So for example, this part, let me take. So this part is, I will first name these two things. So this one is U, this one is U, and this one is V. So the circle on the left is corresponding to U, and the circle on the right is corresponding to V. It need not be circular, I mean, it's just a shape. So whatever elements are in this common region, this is the common region between U and V. So some elements are here. Okay, so some elements are only unique to U, some elements are here, and some elements are only unique to V. All right. The Venn diagram is drawn like this, right? So now we try to evaluate this expression, that what happens here. So right hand side is clear. Right hand side is the entire circle U. Okay, so let's do the left hand side. So V minus U is whatever is in V but not in U. So V minus U is this part. So I will probably color it, let us say red, or yeah. So this red part, this part, which is exclusive to V. Okay. So the elements which are here are only in V but not in U. Okay. So this part is V minus U. So this part. So now we know that what is V minus U, this part, this crescent part. So what is U minus this crescent part? So U is this entire thing. And from here you remove all the elements which are in this part. But these two parts are disjoint, right? So U and V minus U have nothing in common. So even if you remove V minus U from U, nothing has really happened to U. So U remains unchanged. There is no change in U, isn't it?
Yes. So they should be disjoints, right? I mean,
What is the meaning of disjoint? Disjoint means there is no common element.
yeah.
So what does disjoint mean? So in this case, we can see that they are not disjoint. There is some common elements, but still we can see that the left hand side and the right hand side are same. There is no need for the sets to remain disjoint in the first place. So is it understood why the sets can be anything?
Yes.
On the other hand, one of the options is if you have the set U as a subset of V, then what happens? If the set U is a subset of V, which is option C, then we have a Venn diagram like this. I'll draw that situation. This is U. I'll make it slightly smaller so that it can become a subset. This is U. This is a subset of V. This is the other situation. This is a situation of uh, the third option. So in this case, what happens? Uh, V minus U we will check. V minus U is this part, this crescent part. So this part is V minus U. Okay. So U is the smaller circle.
Sure, actually the V minus U not win in this part because the common element of V and U, if this is there, then it is again not been considered as the V minus U.
So what is V minus U according to you?
Now, what are the elements in V and U? If it is not common, as well as only exist in the V, that part only came
Yes,
into the.
yes, yes. So that is the part, no? So V is a larger circle, U is a smaller circle. So whatever is in the larger circle but not in the smaller circle is V minus U. That's what I have marked, this red part. Does it make sense? Ashutosh, are you convinced?
I'm convinced, but I again doubt that if in the circle totality, in the V,
Yes.
again the parent of common element, then, how to
The
take it
common,
from the.
what is the common thing between, what is the common part of U and V in this figure?
It is total the U.
Yes. So whatever is outside of U, that is V minus U.
Yes, yes.
That's what I have marked.
Okay.
So, so this part, again, now you consider this once again. So U minus this red part doesn't affect U at all. So left side and right side are U, same, both are U. But it is not necessary that U should be a subset of V, because we have seen this common situation, the most general situation, that U and V have some overlap, some regions are common, and some region is common, and some region is unique to U, some region is unique to V. Even in this situation, we are able to see that the left hand side and right hand side are equal. So there, even if you do not impose any restrictions on U and V, in the general setting also, this equality will be true.
Now we cannot say that it is a subset. It may be different.
That is what I'm saying.
Yes, yes.
It need not be any. So I'm answering Salma B, who said that U should be a subset of V. I'm saying that that need not be the case.
No.
Okay, sir, I am getting it.
Yeah. So that's what they're saying, that U
So,
minus. Yeah, go ahead.
so the answer should be the sets U and V should be disjoint. Will that be the answer?
This is the answer.
I feel, yeah, this is true for any U and V.
Let's do it programmatically. I tried to do it diagrammatically, which you're not able to appreciate, some of you. So let's do it on the program. So this is a question. So what is the most general condition that guarantees that U minus V minus U is equal to U? Okay. So so we'll define two sets first, U and V. Okay. So what sets shall we take? So first of all, yeah, we can take any sets. We'll take two sets U and V such that there is some intersection between U and V, and some elements are only in U and some elements are only in V. Okay, the most general setting. Okay, so let's do that. So U is set. So let us say 1, 2, 3, 4, 5. And V is, let us say, uh, starting from 4, 4, 5, 6, 7, 8. Okay. So now, so let us print V minus U first. So what should be in V minus U?
Six, seven, eight.
Okay. Yeah, so we have 6, 7, 8. The order doesn't matter. We have 8, 6, 7 anyway. We can sort it, but yeah, we have 6, 7, 8 because it's a set. It's not really ordered. So now let us print U minus V minus U. So we have the set U itself, 1, 2, 3, 4, 5. So even if there is some common elements, the sets even we are not disjoint. Are they disjoint? No, they have common elements. 4, 4, comma 5. These two are the common elements. So even if they are not disjoint, so we can see that U minus V minus U is the set U itself. Does that make sense?
Yes.
So therefore, the most general condition for which the left hand side is equal to right hand side for sets U and V is that for any sets, it doesn't matter what U and V. This is true for any U and V. Need not be disjoint, and U need not be a subset of V. Okay. So you think about the next question. If you have any questions still on the first question, you can ask me. Okay, so what are the symbols mean? U or V. This is actually union.
It's a union.
Yeah, so this is logical OR, but in Python it means union. And this is U caret V. What does this
Disjoint.
mean?
Disjoint.
Symmetric. Uh,
Yes, symmetric difference.
So what is the difference of difference and symmetric difference?
one,
Okay.
that U and V should be disjoint.
Okay. So we have an answer, which is option A, that U and V should be disjoint. Okay. So now I'll explain what is symmetric difference. So I'll just copy the condition again. Shall I do it with a diagram or shall I do it on the program console?
Diagram itself, please.
On number representation, it will better.
Okay, let's do that on the program first. We'll do that after that we'll do it on the whiteboard. So this is the second question. So this is the other condition. All right. So forget this now. So what is U or V? So let me print U or V. It is in fact union. So all the elements would be printed without repetition. So only distinct elements will be printed. So 4 cannot be printed twice. All the 4 is there in both the sets. So let us see. So 1, 2, 3, 4, 5, 6, 7, 8. 4 is ones, 5 is also ones. Although 4 and 5 are in both the sets. Okay. So let's see what is U caret V. Okay, so symmetric difference. That means only those numbers which are exclusive to U, 1, 2, 3, and those numbers which are exclusive to V, 6, 7, 8. So that is the symmetric difference. That is actually U minus V union V minus U. So U caret V, you can also think of it as U minus V union V minus U. These two things are equivalent. So I call it symmetric difference. So difference means U minus V only. Symmetric difference means U minus V union V minus U. Does that make sense?
Yeah.
So it's a one type of union.
Yes. So diagrammatically, if you want to see, So yeah, I'll just copy it once again. So these two things we are going to see. Oops, what happened? Just a second. Where did I lose it? So U or V means everything that is in the union of U and V, and U caret. Okay, I have to. Okay. U caret V means only the part which is exclusive to U union the part which is exclusive to V. Okay, so this blue part and the V part. So the question is, in which situation the blue part union the red part will be equal to the entire thing? That is the question. So what do you think?
Sets U and V should be disjoint.
Yes. Is there anybody who thinks something different? So clearly, if you look at the diagram, if this green part is yellow part is not there, then the entire thing U, U union V would be the blue part and the red part. So in other words, if we have two circles like this, which are disjoint, then we have a situation where U union V and the symmetric difference of U and V, that means U minus V, which is U itself, union V minus U, which is V itself, is same. So the yellow part is not there. As we have seen, U caret V, that is a symmetric difference, the part which is exclusive to U, which is the blue part, union the part which is exclusive to V, that is the red part. This is equal to the entire thing when the blue, this middle part, this common part is not there. This yellow part is not there at all. That's why U and V should be disjoint. So for example, let's see, for in this case, forget the last line which I have written for understanding. U or V is something, run it again. U and V is the entire set, uh, U union V. U caret V is only the equal parts. So if I remove 4, 5 from both the sets, so that the set U and set V become disjoint, then I run again. So U union V is identical to U symmetric difference V. Are there any questions?
No, sir.
So we'll go to question number 3. Suppose we insert 19 into the mean heap 17, 25, 42, 67, 38, 89, 54, 98, 89. Then what is the resulting heap? So you try to construct the
after
heap.
1390.
Sorry. So you take a few minutes, try to construct the heap and try to do the insertion operation. I'll give you a few minutes, then we can talk. There is an answer. Arun Ram has given an answer on the chat. Let me check it. So Arun has inserted 19 between 17 and 25. So 19 is in the second position. All right. Remaining things are as it is. There is any change in the remaining things? No, I think. Gahan has also given an answer. Okay, so he is saying 17 followed by 19 followed by 42 followed by 66. Okay, so his answer is different from that of Arun. We'll check both the answers.
Is that correct, sir?
Salma is saying same. Yeah, just wait 1 minute. Let everybody try. Salma is saying same as in okay, that of Gahan. All right. Any other answers? So how many of you are able to construct the heap? So you have a description of the heap in terms of a list. From here you have to construct the heap. So let me construct the heap and then insert 19. Then we will see which answer is correct. Yeah, I think this is large enough. All right. So we have a mean heap. So the minimum element is at the root. Okay. So what is the minimum element? 17. 17 is at the root. So I will draw it. So here is 17. And in the list representation of the heap, 17 is followed by 25. So 25 is at the left child of 17. Okay. And we have 42. So 42 is in the right child of 17. And so on. We have to make a complete binary tree as far as complete, means as far as possible complete. It's almost complete binary tree we are going to make. So then we have 67. 67 is followed by 38. So these two things will come where? 67 and 38 will come as a child of which node?
25.
Yes. We are going to go line by line. So if you have understood so far, you will be able to construct this mean heap from the least representation. 67.
Sir, I have a query. We should not
Yes, yes.
sort. We should not sort it, or as
No,
per
no,
the
this is
same
uh,
sequence. We follow.
we don't have to sort it. This is the representation of the heap as a list. So we were sort of doing this is what I'm going to call uh, this is like BFS, that is level wise we are going from left to right.
Okay.
It's basically a breadth first search. In the breadth first search order, you have been given the numbers in the mean heap.
It is always like this only for minimum heap means.
That is how the convention is. That is how that it is there in the lectures.
Okay. Okay.
You can do it in your own way, I think. It need not be hard and fast. So now 67, 38 followed by 89 and 54. So this is level 3 completed. Level 3 completed. If you consider the root level as level 1, then level 3 completed. Then in the level 4, we have two more numbers, 98 and 89. That is going to go as a child of the first node in the level 3. So 98 followed by 89. Okay. So this is a description of the mean heap as per the list representation. Now you are going to insert one element. What is that element? 19. Okay. So where shall we insert 19? As a child of which node shall we insert 19 to begin with? '38. Yes, Mukesh Sharma is right. So we have to find a almost complete tree. So this tree is not complete. This fourth level is not complete. So uh, whenever the next element will come, it will come as a left child of 38 because it doesn't have any child in the previous level. Okay. And it is next to 67. So 19 will come here. So now I'm going to insert 19. Let me make it new, give it a new color. Let's make it blue. So it's a newly inserted node. So I'm going to insert 19. Let me make it blue. So 19 is inserted. 19 is inserted into the mean heap. But is it a mean heap after the insertion of 19?
No.
No. Why is it not a mean heap?
I mean, max is maximum elements. The Above 19 is already there, so that has to be rearranged now.
Yes. So what is the mean heap property? Mean heap property is that if you look at a node, its children should be larger. So the parent should be minimum. The parent should be smaller than the children. Okay, that is why the root node, which is the sort of you know parent of everything else. It's not the parent of everything else. It's the parent of two nodes only. But since it's a mean heap, so at the root we have the minimum number, and the mean heap property is that the parent node should be smaller than the children. Okay, so transitively, the parent node should also be smaller than the grandchildren and so on. So here we can see the parent is 38, but the child is 19. So the mean heap property gets violated. So we have to fix it. So that is the purpose of the question, that how do you fix it? So how do you fix it?
Take to if we take to level 2.
We bring it to level 2 in some mechanism.
Yeah.
So the mechanism is uh, we do swaps where the violation has taken place. So 38 is the parent of 19, which is a violation. So we will swap and make 38 the child of 19, and we will do this step. Now, do we have a mean heap?
No.
Why?
Again, 25 is greater than 19.
Yes, yes. Yes, so we have a violation here. So again, we are going to swap. So now we have this situation. Now, do we have a mean heap?
Yes.
You don't have to check anything. Just check 19 and 17, because everything else already the mean heap property was holding. So we check 19 and 17 and we see that okay, 17 is smaller than 19. So we have a mean heap now. So now this is the insertion of 19 completed. Now what we will get is the output. We are going to present it as least representation. So again, 17 is the first level, followed by 19, comma 42, comma 67, comma 25, comma 89, comma 54, comma 98, comma 89, comma 30. Did I make a mistake? Looks to be correct. Looks to be correct. Now we can verify what people were saying. Gahan and Salma, we were saying that it is 17, 19, 42, 67, 25, 89, 54, 98, 89, 30. That is correct. Whereas the other person, Arun Ram, was saying something different, but that is not correct. But I would like to know why Arun Ram got that answer.
Sir, I have added a 25 mistakenly, sir.
Okay, okay, fine. So I hope that you are now able to rectify the mistake.
Yes, sir. Yes, sir.
Okay.
Sir, in case of max heap,
Yes.
uh, is it the same procedure or adopted in case of mesh? The root one is the max one, then the following condition is again to be followed.
Yes, yes. So in the max heap, the root is supposed to be the maximum element, and the max heap property is that the parent should be larger, strictly larger than the children. So at any parent-child relationship, if you see that the parent is smaller than the child, then you will swap.
So if you consider these examples, then can we do it right now?
So in this example, we cannot do it because this is the presentation of a mean heap. So if you are given
Okay.
the presentation of a max heap, then the largest number should come first. For example, in this case, you see 17 is the smallest number. That's why it has come first in the least presentation.
So 98 would be come first if it is a max case.
Yes, 98 is the largest number. That will be the first element in the list.
Then in this case, if it will take the 98, then next element to which one to be taken? 89 or 17? Is it left side or right side? How it will come?
I'm trying to understand what you are asking.
In
So I
this
think
case also, sorry, in mean if also, if suppose the 17 not been first one, if 17 not been middle part of the sum one, the element,
Mhm.
then how to take the other elements?
So you follow the same algorithm.
No, sir, already known. My question is that if instead of 17 is the first element, if it is in the fourth element,
So you are saying that you start with an empty heap and then you insert these numbers one by one. That's what you are saying?
no, sir, my question is that replace the 17 as 25 and 17 brings to 67 position. 67 is the 17 position.
We will do what you are saying. Just give me a moment. So what do you want to do?
17 to be in 67 position and 67 to be in 17 position. This is 67, this is 17. In this
Okay.
case, how the diagram to be? Hello.
Okay, so it is neither a mean heap nor a max heap.
Mean if.
So I'm saying that this is neither a mean heap nor a max heap. Because in a mean heap, the smallest number should come first, as is depicted here. And in a max heap, the largest number should come first. But I think your question is like how you insert elements into an empty heap and maintain the heap property. I think that is what you are trying to ask. Am I right?
No, no, sir. My question is that in this scenario, can we make it which one is how to design the mean if?
No,
Can
no,
we
we
do it?
can't do any such thing. We can't do any such thing.
Okay. That means in every starting position, that should be mean if should be in the first.
Yes.
In makes if cases, it is last
And
or
the maximum element should come first.
okay. Thank you.
Okay. Any other questions? So there is a similar question now. Okay, so okay. Suppose we execute delete min twice. So on a minimum heap, you can delete the minimum element which is at the root. But once the root element is deleted, then how do you restore the heap property? And that's what is the purpose of this question. So I will let you do this. This will take a couple of minutes. Maybe I think there is no need to take break today. Okay, I give you 5 minutes to think about it. I not in yeah, fine. I'll give you 5 minutes. So first try to construct the heap as per the list representation. So level by level, you have to try to make it an almost complete binary tree. Then delete the root, and then you have to do something to restore the heap property. So Gahan has an answer. Okay. Fine, we will check whether Gahan's answer is correct or not. So Salmavi is seconding Gahan. All right. Rimi has another answer. Mukesh has also found an answer. Yes, delete win has to be performed twice. Ashutosh has found an answer. So what Ashutosh has found is different from that of Mukesh, but I think the answer of Rimi and Gahan are same. Okay, I'll give you 1 more minute. The rest of you. So I think the other people are not able to find the answer because they do not. Okay, Manoj has another answer. Looks to be the same as that of Rimi and Gahan. So those of you who have got this answer, this 29, whatever Manoj is saying, just tell me, answer one question that once you deleted the root, then which element you brought into the place of the root? The last element. 58. Okay. So in the original list, 58 is the last element. Yes. Okay. So now people realize that after you delete 13, then 58 has to come at the place of 13 at the root, but that will violate the mean heap property, and then you have to do the swap steps. You have to keep doing the swap steps as long as the mean heap property remains violated. So once you restore the mean heap property, you do one more deletion of the root, and then do the same thing. and then you will be able to get the answer. So I will give you time, but so I will just also draw the this thing. I will draw the mean heap, the original mean heap, and then I'll perform two delete mean operations on this. So here is the description of the mean heap in the least format, and 13 is the root. 13 is the root. Okay, let's make it black. So 13 has two children. 29 and 24. I'm constructing the original heap. So then we have 67 and 52. If I make a mistake, please point it out, which can happen if I'm not attentive. 67 and 52. Then we have 89 and 45. Then we have 98 and 79. Then we have 58. So this is the description of the heap in the tree structure. Is this correct? The original heap.
Yes, sir.
Yes, sir.
Okay, so now I'm going to do what? I'm going to perform delete min twice. So what is the minimum element? The minimum element is at the root. So I'm going to perform delete min. So what happens when I perform delete min? 13 is deleted. I want to perform delete min twice. So 13 gets deleted. So 13 is no more there. We deleted it. Now in this tree, the last element is 58. That is the last level, last element is 58. So I bring this thing here at the root and I check whether the mean heap property is violated. So is 58 smaller than both the children of 58? That's what I have to check. But turns out that 58 is larger. So what we will do, we have to do a swap. Which one shall we swap? Which out of these two, 29 and 24, we have to swap with 58?
The minimum.
Yes, yes. So out of 29 and 24, whichever is smaller, that I will swap with 58. So 24 is smaller. So I bring this guy here, bring this guy here. So now I check whether at this point where 58 is seated, there is a violation of the heap property. So is 58 larger than both its children? No. 58 is, sorry, what do you have to check? 58 is smaller than, or yeah. Is 58 smaller than both of its children? No. 58 is smaller than 89, but not 45. So 45 and 58, there is a violation. So I have to swap once again. So now I'll check whether at 58 we have the mean heap property satisfied. So it is vacuously satisfied because there are no children 58. So its children are supposed to be larger, so there is no violation at all. So this is what we have got after the first delete min operation. What happens if both the children are same? We just pick one of them arbitrarily. All right.
Sir, if both are 45, it goes to left child, I think, because heap property is going from left to right and top to bottom. So 45 will go to left child if both are same, I think. Is it correct?
Okay, what are you saying? So we have this situation here. 58. Oh, you're saying that both this is also 45, this is also 45,
89
you're
is
saying.
45 and that one is also 45. There is no 89. Suppose there is 45. Both the childs are 45. It will go to left child.
Is there a problem if I take one arbitrarily out of the two children?
No, like when we studied the heap properties, it goes from left to right and top to bottom. So it will be like that or something different.
So you're saying that the left child should be smaller than the right child.
No, not that. If instead of 89, there is 45 and right side also 45.
Mm-hmm.
Then what will happen?
I don't know. Let me check. Give me 2 minutes. I was of the opinion, I was of the view that you can take one of the children arbitrarily. Let me check once. So what I can see is from different sources that if both children of the new root node have the same value, you can swap with either one because the heap property will be maintained regardless of the choice. So whether you move the left 45 or right 45, the heap property is maintained. It does not matter. However, for consistency in implementations, a common approach is to swap the root with the left child. So the left 45 you can swap with 58. That's a common approach. It's just depends on individual. Some implementations might swap the child that maintains a more balanced heap. Okay. But in summary, both children have the same value means you can swap either one. That's what I can see from the source.
Okay, sir. Okay.
But does it really matter? Because I don't think it really matters because the list representation may remain the same, isn't it? Or maybe not. So the list representation may not remain the same. It could give a different list representation. So far, as far as the exams are concerned, you are given distinct elements in the heap, but it's a valid question. So I do not know if there is a convention. I think there is no convention. You can do it the way you like. And in the exam, if there is a question like this and you do something which the examiner doesn't do, then you can raise your concern. I think that should be possible. I don't see a convention, at least uh, immediately. So he after the first delete min operation. So now those of you who did not get the right answer, the right answer is what Rimi is saying, or Kahan is saying, or Salma B has written, or maybe Manoj is also, I think, saying the same thing. So now I'll perform another delete min, then we will get to the right answer. So yeah, what has happened? Okay, so there is no requirement of this edge because 58 was here, we move 58. Yes, go ahead.
And the first one, the 58 should come in place of 45. 45 would go to 58. No? After first deletion. Yes. Then the second
Yes.
option would be second. Okay.
Now we delete once again. So deleted. So the last element is 79. We bring it here. Now what do we have to make any swaps?
Yeah. 29.
29 is smaller of the two children. So 29 is swapped. Again, we check whether 79 and its children are all right in terms of the heap property. No, both of them are smaller than 79. So the smaller of the two children is 52. We move it here and move 79 down here. And at 79, it is vacuously satisfied, the heap property. This edge is no more there. So this is the final heap after two deletion operations. So we're always deleting at the root. So we are always deleting the mean. We can write this in terms of the least representation, layer wise or level wise. So first level 29, second level 52, followed by 45, third level 67, followed by 79, followed by 89, followed by 58, followed by 98 in the last level. So this is the answer. I think many of you got it correct. Krishna 29, 52 is 45. Yeah. All right, fine. You're right. Mukesh is saying not necessarily. I don't know what is the context. I missed it. Then we may have different answers if we, yeah, I mean, I think arbitrarily one could choose if there is no convention. Twenty-four 67. Ashutosh didn't get it right first time. I think Ashutosh needs to recheck his calculation.
Yes, sir. I was wrong at that time. Okay.
Wow. So we'll go back. If there are any other questions, you can ask me. Otherwise, we'll move to the next question, if any.
In the set, only two some functions are there, or the union and symmetrical differences. There is any other?
Other things are also there. Intersection is also there. We'll do certain things. So see, this is normal difference, V minus U. This is union. This is a nice question. So this is union. This is symmetric difference. There should be one intersection function, no? Intersection means whatever is common between U and V. So anybody knows how to write intersection?
Ampersand symbol. Ampersand symbol.
Ampersand. So this is intersection. What else can we do between two sets? Is there anything else we might be able to do?
Elements present in both the sets, sir.
Yes, yes. But is there anything else we can do with sets? Any other operations? So we have seen union, symmetric difference, set difference. So U minus V set difference. I think I can write it explicitly. So U minus V means set difference. So whatever is in U but not in V. Okay. So now we'll write some more stuff. 4 and 5. So now we're going to run this program on two lists. I mean, lists are converted to sets like this. So one more thing is that, so if you have multiple elements in this list, which is possible, but in the set only distinct elements will be taken. So first let me print U and V. Duplicates are removed in a set. Okay. So first you write a list, convert it to a set like this. So we're taking union here. This is symmetric difference. This is intersection. Okay, maybe union followed by intersection makes more sense. Set difference is simpler. I put it before symmetric difference.
Disjoint was there?
Please come again.
Disjoint which question? Is there anything come disjoint?
No. So if U intersection V is empty, that means U and V are disjoint. So you can check whether it is empty or not. Now I'm going to run this program. So now you can verify. This is the first set. There are no duplicates. Although in the list there were duplicates. In the set there are no duplicates. Yeah, here also there are no duplicates. This is union. U vertical bar V. This is intersection U ampersand V. This is set difference, that whatever is in U but not in V. So 1, 2, 3. This is symmetric difference, that is whatever is exclusive to U union whatever is exclusive to V. So 1, 2, 3 are exclusive to U. Union 6, 7, 8 are exclusive to V. So 1, 2, 3, comma 6, 7, 8. So you can use these things in your program just for understanding. So more important is to be able to write programs for doing things, for performing small tasks or complicated tasks. Okay, so these tools are helpful. So the purpose of this course is to be able to learn, how to write code for small things or small tasks, not to solve the assignments. So, I mean, solving the assignments will be useful. So, are there anything else on this matter? The operators union and intersection are confusing in Python. Confusing in the sense, so union is distinctly represented when compared to intersection. Ampersand can be used for union while the vertical bar can be used for intersection. So you're saying that the convention is, so what you are saying, if I understand correctly, is that you would prefer to use ampersand for union and you would prefer to use the vertical bar for intersection. That is your preference. That's our, okay. Yeah, but we have to go by the convention what the makers of Python have used. But I understand your point. So always try to visualize in terms of the Venn diagram. It's very useful. In such questions, you can just use Venn diagram which you have seen in your 8th standard math. So at this point, we have come to the end of this session. There are no other questions, as you can see. So next week, we will see certain things, abstract data types, some class concepts. Classes are object-oriented programming concepts, some advanced stuff like search trees. Okay. So we have 2 more weeks left. The last week is the most interesting, where we will see how to use dynamic programming, which is a very powerful technique for designing algorithms. But beyond 8th week, I'm planning to offer an extra session. So you can suggest me what you want to discuss or what you want to see in that extra session. In that extra session, we can discuss anything, so to say. There will be no uh, restriction on us to discuss any questions or quizzes or assignments. So you give it a thought. We'll probably have one extra session on the last on a Monday, which is subsequent to the last Monday in this course. So you give it a thought. You can suggest me in the next class what you want to hear and the extra session. All right.
Sir, actually, if we will face something problem in this period, or if we'll mail something to you regarding some clarification in between, can you give some solution?
Depends on my constraints. If I have time, I will respond to it. And if
Okay.
the question is related to the assignments of the current offering of the course, where the deadline is still not passed, then I won't be able to answer.
Okay. No, sir. No, the fundamental things, if will some clarification, doubt clears.
Yes. You
Okay.
can mail me.
Okay, sir.
Manoj is asking what are the conditions for max heap and mean heap. So a heap. So a heap is an almost complete binary tree. For example, if you look at it, all the levels are complete. So first level, one element is there, no other space left. Second level, two elements are there, no other space left. Third level, four elements are there. Fourth level, how many elements should be there in a complete binary tree? So I'm considering the root as the first level. Yeah. So in the kth level, there should be 2 to the power k minus 1 elements in a complete binary tree. But what we have maintained is it's an almost complete binary tree, because in the last level, all the positions are filled except possibly a few, but there are no gaps in between. So now the heap property says that you consider any node and you look at the children of that node. For example, I'm considering 19. So both the children should be larger than the parent node. That is the mean heap property. All right, Manoj. At any node, you should be able to verify that the children are larger than that node. That is the mean heap property, that the parent is minimum. I mean, minimum with respect to the children. And if the parent is smaller than the children, then the parent would also be smaller than the grandchildren and the subsequent descendants. That is the mean heap property. And the max heap property is just the opposite. So you consider any node, the children should be smaller, strictly smaller. So therefore, in a max heap, the largest element is where?
Root.
At the root. Because if it is not at the root, where could it be? Wherever it is, it cannot have a parent which is larger than it. Then we'll have it cannot have a parent which is smaller than it by the main heap max heap property. So that is the idea of main heap and max heap. I hope I have answered the question to Manoj. Kajal is asking how can we convert heap into list.
Yes, sorry, it is convert.
How can we convert heap into, so heap is generally, you mean in the programs, in the implementations?
Yes, yeah.
So in the implementations we have seen lists only. Have you seen heaps explicitly?
No, like the tree I have, probably if I have a tree and if I want to collect the data and write the program for it, then how should I start with that?
So as you have seen in the videos, what you can think of it as, so for example, this tree you want to represent. So you represent it as a list. So what is the, for example, I think this is the corresponding list now. So you know that in a list representation, the first element is indexed 0, the second element is indexed 1, and so on. Then if you look at, for example, 42, 42 is the second indexed element in this list. So when you want to think of it as a tree, then you should, who has unmuted? Yeah, so how to think of the list? So you are implementing as list only, but you have to imagine the list as a tree. To be able to do that, you have to identify that given a node, for example, given 42, what is its parent and what are its children. That's all you have to identify. So how to do that? So remember, 42 in this case is indexed 2. So how they do it is that, if I think if I remember correctly, so if a node, so just listen, for the ith index node, ith index means in the list. In the list, if you're looking at the ith index, in this, let us say 42 is a second index node. The parent is given by, the parent is at index. Anybody knows where the parent would be? This we have seen in the videos.
Okay.
See,
Where?
Okay. Yeah.
No, so I want to know where the parent is. So 42 is at 2, its parent is at 0. 19 is at 1, its parent is at 0. So it's at I by 2. Is it I by 2?
2.
So you have to take floor also. So you take floor of I minus 1 by 2. So now you think about it. For example, 89. What is 89's index in this array? 1, 2, 3, 4, 5, 5. So parent of 5 is 5 minus 2 by 2. 5 minus, 5 minus 1 by 2. Floor. That is 4 by 2. That is 42. You got it. So that's how you have to imagine that, okay, I know that if the ith index node is something, then the parent is here. So that's how you implement trees as lists. So how do you find the children? This is also we have seen. The children are, I think you can look it up. It's very easy. That where are the children? So that's how you can imagine a tree, but implement as a list only. if it is complete or almost complete. Yeah, so Gahan is right. The two children is like, if you're looking at the ith note, so Gahan is saying that the two children are 2i plus 1 and 2i plus 2. Makes sense. Anything else? So you give it a thought what we shall discuss in the extra session. Then you can let me know whatever is your preference. That is for your benefit. We will spend some time, and then we will conclude this course from my side. If you offer an extra class, then it will be after exam. Why? When is the exam? See, today is Monday, 3rd March. Next Monday is 10th March. We'll have 7th session. Uh, March 22nd. Okay. Oh, you are right. No, March 22nd. So we have to do it before March 22nd. So you are right. Okay, so 17th March is our last meeting. So which day is convenient before March 22nd? Is there any preferred date?
Weekend will be preferable.
Weekend, okay. So next class I will tell you what is the date for the extra class, but Khan is right to point out. Thank you for pointing out. Salma, we thank you for pointing out the exam is on March 22nd. So we will do it before March 22nd. In fact, we will do it even earlier. So what we can do, we can discuss the 8th week slightly early, so that on 17th we can have the extra session. That is also possible. I'll tell you what is the plan next session. So I think it was a long session without breaks. Okay, what is this program about?
Yeah, I just did one program, small program. Here I faced the if unit is equal to k, capital K or small k, that condition only it's getting true. It is not going, if I press L, it's not going to the other condition.
Okay, I'll copy it. I'll try to see if what you're saying is reproducible. So you are taking input and you keep it at weight. You're taking another input, and this should be some character K or L.
Yes.
Okay. Then you are printing what is the unit. Then if the unit is K or K, then you multiply weight into 2.205. Okay.
To get in pounds, basically.
Okay. 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 Weight in pounds. I see.
Hmm.
All right. If it is pounds, then you convert it to kg.
kg.
What is the issue?
Issue is if uh, I put in pounds, it's again multiplying only. It's not a dividing and giving in kg.
Okay.
Basically, the first condition is getting true
Mhm.
always. if I type L also, L means it should take as consider as pound and should give in kg. What I understood is small k I should not use. That's what I got. It should
So
be always.
why don't you ask whether it is kg or pound? Okay, fine, that's not a problem. So let me try to do that. So let us say I start with an input 10, it is kg or pounds, I don't know. Then I say k. Okay, so it is always going to this block.
First one, yes. If I put L also, it is going to that block only.
Okay. So ideally it should, with L it should come here and it will divide by 2.205 and you should be able to see it. All right, let's do that. Uh, all right, all right. It's multiplying, no?
Yes.
Oh, you have not given the other thing. That is the problem. You don't write or like this. You should write if unit is equal to k or unit equals to k. Then it works. See, what is the problem is k is always getting to non-zero, evaluating to non-zero. That is the problem. What happened? Unsupported operand type. Uh, we have to write within brackets. What was the
Seventh line, sir. Seventh line.
okay? What is the issue in seventh line?
One more bracket here, sir.
Oh, okay, okay, okay. This is the issue. Thanks. So now we have 3 left brackets, 3 right brackets. Yeah, yeah, yeah. Again, there's an issue. Never closed. We have some mismatch in parentheses. Okay, 1 bracket, 2 bracket, 3 bracket, 4 bracket. Okay. Unsupported Robert type. Okay. So it has come to this block. That is true that it has come to this block. Earlier it was
Sir,
going
we
there. Now
should,
it has come to this. Go ahead.
sir, we
You
should
want to
use,
say something?
sir.
Yeah.
Sir, we should use bracket after the weight. I think.
Yeah, there's so many things. Let's not do it. Why are you converting to string? So forget integer. So keep it weight by 2.205. Forget everything else. This should work. Unsupported operand type for greater str and float. Why don't you keep a variable which is the conversion factor and call it and put 2.205 here.
Okay.
And you do it this way so that there is no mismatch issue. You see,
Okay.
that doesn't work. So weight is integer. Good. So weight by, we have a float. That is not working. Can I make it float and it will work? I have not practiced for a long time. Yeah, both things have to be float. So there's an issue. The issue was that integer weight was integer. They were dividing by a float thing, and then that's why they are saying that I cannot divide an integer with a float. So I made weight also float. That's why it has become corrected now.
Okay. Got it. So unit I have to give both the places. R means I have to give both the places.
Yes. Otherwise, what happens if you say k? K is non-zero. So this basically checking one of these things are true or not. True means non-zero. So k itself is non-zero. So better to not hard code things. Better to take a variable which would be multiple used in multiple places.
Okay.
Yeah, thank you. Is there anything else? Anybody? Any
Thank you,
issues
sir.
they have faced? Yeah, weight was string. That's correct. So weight was not an integer. It was a string, as Khan has pointed out. Integer can be divided by float. Yeah. So when we take weight, so it was I was giving 10. It was processed as a string. That's why you have to make it float or yeah, float is better because the weight could be non-integer also. Yeah. So I think at this point we can conclude this meeting unless there are other questions. All right, I thank you for joining, and I'll see you again next week.
Thank you, sir.